Wednesday night homework, October 30th, problem 2. Find the length of each hypotenuse to the nearest hundredth. So we have a right triangle. We know the Pythagorean theorem is a squared plus b squared equals c squared. And let's take a look at the right triangle and identify our variables. So we know we're solving for c, and we'll call a equals 7 and b equals 8 and plug those into our Pythagorean theorem. So we have 7 squared plus 8 squared equals c squared. Next step is 7 squared does not mean 7 times 2. It means 7 times 7, which is 49, plus 8 times 8 is 64. And now we need to add 64 and 49. So I like to write my numbers vertically. When I add 64 plus 49 gives me 113. So this is not a perfect square. So the next step is to take the square root of 113, and we know the square root of 100 is 10, and the square root of 121 is 11. So our answer is going to be between 10 and 11. So for number 2, you can write between 10 and 11. You can also you can estimate your answer. So 113 is 13 away from 100 and 8 away from 121. So we know our answer is going to be greater than 10 and a half because 113 is closer to 121 than it is to 100. Number 4 we did in class, so we're going to skip that. Number 6. Now we're missing the measurement of one of the legs in the right triangle. So we want to get in the habit of writing the Pythagorean theorem and then underneath it substituting our values into the theorem. So we need to identify the hypotenuse. The hypotenuse is always opposite the right angle. So I'm going to draw an arrow, and so 8 is our hypotenuse. So let's substitute that for c squared. B squared we don't know. We're solving for that missing measurement, and a squared is 6. So 6 squared. So we're going to multiply 6 times 6 to get 36. Multiply 8 times 8 to get 64. And our equation principles tell us when we have numbers on both sides of the equal sign, we need to subtract. Take the opposite, so that cancels. Subtract 36 from 64. And we get 28, so b squared equals 28. So we need to take the square root of 28. So again, it's not a perfect square, but let's think of our perfect square. So we have square root of 25 is 5, and the square root of 36 is 6. So our answer is going to be between 5 and 6. Now, the square root of 28 is 3 away from 25 and 8 away from 36. So our answer is going to be closer to 5 than 6. So I'm going to circle 5 to tell me our answer is going to be closer to 5. And I'll do the same thing in problem 2 to say our answer is going to be closer to 11. All right, number 8. A traffic helicopter flies 10 miles due north and then 24 miles due east. Then the helicopter flies in a straight line back to its starting point. What was the distance of the helicopter's last leg back to its starting point? So we're going to draw a picture. The helicopter starts at this point and travels 10 miles due north. So that distance represents 10 miles. Then 24 miles due east. So this direction is east, and that's 24. What was the distance of the helicopter's last leg back to its starting point? So we are looking for this measurement. Here's my right angle. And so the missing measurement is C, because the hypotenuse C is always opposite the right angle. So let's write our Pythagorean theorem formula, a squared plus b squared equals c squared. So we have 10 squared plus 24 squared equals c squared. 10 squared is 100, 24 squared is 576. We want to add 576 to 100 to get 676, and now take the square root. And square root of 676 is 26. How do I know that? Well, 26 times 26 should equal 676. Let's test to make sure that it does. 6 times 6 is 36. 6 times 2 is 12, plus 3 gives us 15. Add a placeholder. 2 times 6 is 12. 2 times 2 is 4, plus 1 is 5. And we see that it does add up to 676. Okay, number 10. So it gives us the variable c that we're missing. So let's write our Pythagorean theorem. And substitute our values. So 5 squared plus 12 squared. 12 squared is 144, because 12 times 12 is 144. 5 squared is 25. We're going to add 25 to 144 to get 169. And now let's take the square root, and we get square root of 169 is 13. So c equals 13. And remember, when we're missing the hypotenuse measurement, all we're doing is taking the square root of a squared plus b squared. Okay? Number 12. Okay, number 12 is just like number 4 that we did in class. So what you want to do is take out your graph paper and plot these points. So we're going to plot negative 5, 3. So we count to the left 5, negative 5, and up 3. Point goes there. That's negative 5, 3. Then we want to plot 5, negative 3. So 5, 1, 2, 3, 4, 5, and then negative 3. 1, 2, 3. Point goes there. Then we want to plot negative 5, negative 3. So negative 5 is here, negative 3 is here. And let's connect the points. It makes a right triangle. Here's my right angle. So I know that this measurement is C, and then these are my legs, A and B. So how do I calculate the measurement of the legs? Well, I just count, starting from this point, how far is it to this point? So I'm going 1, 2, 3, 4, 5, 6. So that leg has a measurement of 6. Now I'm going to count along the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this leg has a measurement of 10. And now I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared, where my a and b measurements are 6 and 10. So 6 squared plus 10 squared equals c squared. 6 squared is 36. 10 squared is 100. So I have 136 equals c squared. And now, don't forget, we need to take the square root of 136. So let's think of our square root clock that we made in class. So I know the square root of 121 is 11, and the square root of 144 is 12. So my answer is between 121 and 144, so it's between 11 and 12, so 11 to 12. And let's see, 136 is 8 away from 144 and 15 away from 121, so it's going to be closer to 12. So I'm going to circle 12 to tell me the answer is closer to 12. So it's going to be like 11.8. Number 14, we're missing the leg. We're missing the leg. So the shortcut to solve for the missing leg is to take the square root of the difference of the hypotenuse and our leg measure squared. Another way to think of it is, let's use the Pythagorean theorem. So a squared plus b squared equals c squared. So you can either square these two numbers, subtract them, and then take the square root of the number, or just substitute the numbers into the Pythagorean theorem. Let's substitute. So we have a is 4, we don't know what b is, and we know c is 13, 4 squared. Now, of course, I want to take 4 squared is 16. 13 squared is 169. And now I want to subtract 16 from both sides to cancel out the plus 16. So subtract 16, you get 153. So I need to take the square root of 153. So I need to think, okay, the square root of, let's see, square root of 153. So I know it's going to be close to 13, so I would estimate it's going to be between 12 and 13, but closer to 13. So B is going to be between 12 and 13, but closer to 13. How do I know that? Well, because 150 squared to 153 is close to 169 and close to 144. Let's see, 9 away from 144 and 16. Actually, it's going to be closer to 12 than 13. So let me correct that. So closer to 12. Okay. And now just think of a shortcut. So anytime you're missing a leg measurement in a right triangle, just square these two numbers, subtract them, and then take the square root, which is what that says right there. Number 16. Another word problem. So we want to draw a picture. Mr. and Mrs. Flores commute to work each morning. Mr. Flores drives 8 miles east. So we need to have a starting point. So this dot is my starting point, 8 miles east to his office. Mrs. Flores drives 15 miles south to her office. So south is 15 miles. How many miles away do Mr. and Mrs. Flores work from each other? So I want to find this distance here. Well, notice that distance is opposite the right angle, so that is my hypotenuse measurement that I'm missing, my c variable in the Pythagorean theorem. So let's write our Pythagorean theorem. A squared, so 8 squared plus 15 squared equals c squared. 8 squared is 64. 15 squared is 225. When you add them together, you get 289. And now you take the square root of 289, which is, let's see, 17. Let's test to make sure that we're correct. 17 times 17, let's see if that equals 289. And in fact, it checks out okay. So C equals 17 miles. So they work 17 miles apart from each other. All right, number 18. So now we're given our B and C measurement. So A squared plus B squared equals C squared. Now we're dealing with larger numbers. So if you want, take out a calculator. And to solve for A squared, you just, after you square 40 and 41, you just take the difference and then take the square root. So square 40 and 41, subtract them, and then take the square root. Number 20, we have 16 squared plus b squared equals 38 squared. So once again, square 16, square 38, subtract the two numbers, and then take the square root. And last problem, number 22. We have 65 squared plus b squared equals 97 squared. Really big numbers, so use a calculator to multiply these out. So you're going to square 65 and square 97, subtract them, and then take the square root to solve for b.